Okay. So this is the last topic what we have done yesterday.
Sir,
Yes, better.
today we are not doing any problems, sir.
Shall we do some problems?
Yes,
What
sir.
is
Yes,
today?
sir.
Today is Thursday, na?
Yeah, sir.
Yeah, I will do some problems if it is fine with us.
You said right, sir, that we'll
Okay,
do
na?
the problems. You said that we'll do the problems on Thursday and Friday, right, sir?
Okay, then we'll do problems better, not an issue. Shall we start, beta?
Yes, sir.
Sure. Try to take the rough paper along with me and try to write the data and try to do the problem better. So everyone try to take the rough paper and pen and try to do the calculation and try to help me out with the formulas, whatever you know it all. So the first question right now, beta. A circular hole of diameter 2 centimeters 2 centimeter is made in an aluminum plate. Aluminum plate at 0 degrees centigrade. At 0 degrees centigrade. Just stop. What will be the diameter? Just give me a minute, beta. Circular hole of diameter 2 centimeter is made in an aluminum plate at 0 degree centigrade. At 0 degree centigrade, alpha of aluminum is equals to 2.3 into 10 to the power of -5 per degree centigrade. So this is a question for me. The circular hole of diameter, we got a diameter of how much for me? 2 centimeters, is made in aluminum plate at what temperature? 0 degrees centigrade. Coefficient of linear expansion of aluminum is given for me 2.3 into 10 to the power of minus 5 degrees centigrade. Am I audible to everyone, beta?
Yes, sir.
Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Can anyone give me the answer for this one? See, diameter is nothing but what? Length, na? So we need to write in terms of diameter. So diameter at your 100 degrees centigrade will be equal to diameter at your 0 degrees centigrade into 1 plus alpha into your temperature difference. That is nothing but of your delta T. So we need to calculate right now what a circular hole of diameter 2 centimeter is made in an aluminum plate at 0 degree centigrade. 0 degree centigrade. Alpha of aluminum is given for me. The question what exactly is asking is here I'll write with this one. What will be the diameter at 100 degrees centigrade? What will be diameter?
But sir, we can't see anything you're writing.
So your screen is up.
Yes, beta. Screen is stopped. Huh? Ho, ho, ho. Sir, please try to make me host, sir. Now it is visible, beta.
Am I audible, beta?
Yes, sir.
Chalo. Try to do on the board, beta. It is getting stuck unnecessarily. Chalo. Keep the heading there, beta. Problems on thermal expansion. Problems on your thermal expansion. So the first question says for me, a circular hole of diameter 2 centimeter, diameter 2 centimeter is made in a aluminum plate at 0 degrees centigrade. What will be the diameter? What will be the diameter at 100 degrees centigrade? Alpha of aluminum is given as 2.3 into 10 to the power of minus 5 per degree centigrade. Come on, try to do it out. A circular hole of diameter 2 centimeter is made in aluminum plate. This is your aluminum plate. At what degrees? 100 degrees centigrade. So what will be the diameter at 100 degrees centigrade part? The circular hole is made in this one. So initially when the place is at 0 degrees centigrade, we are making a hole in this one. We are making a hole in this one. And diameter of this one is given as how much for me? 2 centimeter. This is given as of your 2 centimeter. Now when the plate is being gone to your 100 degrees centigrade, when it is at your 100 degrees centigrade, the whole diameter is also increasing. The whole diameter is also increasing. So diameter at 100 degrees centigrade is equals to how much? So how do you write this one? Diameter at your 100 is equals to d at 0 degrees centigrade into 1 plus alpha into your delta theta. Diameter is nothing but length only, no? So that is equals to your d naught. Diameter at 0 degrees centigrade, how much it is right now? 2 into 1 plus alpha. Alpha value is how much for me? 2.3 into 10 to the power of minus 5 into T2 minus T1. T2 is how much? 100 minus 0. So if I simplify this one, this is nothing but of your 2 plus this one is nothing but of your 1 plus 2.3 into 10 to the power of minus 5 into your 100. 100 is nothing but 10 to the power of 2. So minus 5 plus 2 will become for me how much? 10 to the power of minus 3. So this is a 2 into, this is nothing but 2 into 2 plus this is nothing but of your how much for me? 2. So I'll write this one as of your 2 into 1 plus 2.3 into 10 to the power of minus 5 into 2. This will become for me minus 3. Isn't it? So simplify this one and see how much I'm getting the answer. Can anyone give me the answer for that one? See. How much it is? Am I audible, beta?
Yes, sir.
Okay. I hope you got everyone. This was an aluminum plate, beta. When the plate was at 0 degrees centigrade, when the plate was at 0 degrees centigrade, a hole was being made in which the diameter was how much for me? 2 centimeter. So diameter at 0 degrees centigrade is how much for me? 2 centimeter. When the plate is increased to 100 degrees centigrade, that means the hole will be expanding. So at the time, what will be the diameter of this hole is asking. So diameter of the hole is equal to d naught into 1 plus alpha into delta. See how much I'm getting faster. And that's none. Are you doing or not?
So 2.0046, sir.
2.0046 centimeter. Very good. That
centimeter.
will be your answer. 2.0046 centimeter will be the answer. Clear for everyone?
Yes,
Over?
sir.
Okay, chal. Let us try to go for the next question. Question number 2. Question number 2 says right now for me, an iron rod and copper rod, and iron rod and copper rod, an iron rod and copper rod lie side by side, lie side by side, lie side by side. As the temperature is changed, as temperature is changed, comma, the difference in the lengths, the difference in the lengths of the rods remains constant, at a value of 10 centimeter. Find the length at 0 degrees centigrade. Find the length at 0 degrees centigrade. Coefficient of linear expansion of iron and copper, alpha of your iron, that is Fe, is equals to 1.1 into 10 to the power of minus 5 per degree centigrade, and alpha of your copper is equals to 1.7 into 10 to the power of minus 5 per degree centigrade respectively. Coefficient of linear expansion of iron and copper are 1.1 into 10 to the power of minus 5, and alpha of copper is equals to 1.7 into 10 to the power of minus 5 per degree centigrade for the given question. See the condition what he has given for me right now in this one. We got an iron rod and a copper rod which are lying side by side. That means this one is right now one rod and this one is here another rod. So first one is of your, say for example, iron. The next one is nothing but of your copper. Side by side. As the temperature is changed, the difference in the length of the rod remains constant at a value of your. That means expansion in the iron and expansion in the copper is same. Like say for example, this one is expansion in the copper and this one is expansion in your rod. So this delta L and this delta L. Delta L of your iron, expansion, and delta L of your copper are same. That's what is telling. As the temperature is being changed, the difference in the length of the rod remains constant. The difference in the length remains for me constant. At a value of your how much for me? 10 centimeter. Is asking us to find out the value at your 0 degree centigrade part of the relation right now. So difference of that length means L of your initial condition, that is nothing but of your iron if I am taking right now. This is for your iron minus initial length of your copper. The difference is equal to how much for me? 10. That means expansion of your iron is equals to delta L of your copper. Difference is remaining constant, expansion should be remaining for me the same. So if I am writing for this one, L naught of your iron into alpha of your iron, that is nothing but of your Fe, into your temperature difference. What temperature difference? Theta initially minus initial temperature is how much? 0. This is the length of your what? Iron. That must be equal to your initial length of your copper into alpha of your copper into temperature difference is nothing but how much for me? Theta minus of your 0. Theta minus of your 0. So in this one, what is getting cancelled? You see, this one and this one is getting cancelled. If I'm simplifying for the given condition, this one is L naught of your iron into alpha of your iron is equals to initial length of your copper into alpha of your copper. So I can get me the length of that one. So find the length at 0 degree centigrade. Length of your iron will be equal to your length of your copper into alpha of your copper divided by alpha of your iron. That will give me the answer for the given condition. Clear for me? So this one I can write as of your L naught of your iron is equals to L naught of your copper into alpha of your copper is given how much for beta? Alpha of your copper is 1.7. Powers are same, so that will be getting cancelled, divided by 1.1. Is that clear for everyone? So this is my equation number, say for example 2, and this is my equation number 1 part of a relation. So from both the relations, see if I'm writing with a red pen right now. I got right now L of your iron, substitute your 2 in your 1. Okay, so L of your iron, how much you're getting right now? Length of your copper in minus length of your copper into this one is nothing but of your 1.1 divided 1.7 divided by 1.1 minus length of your copper is equals to 10. So I'll be getting initial length of what beta copper. I can get the initial length of your copper per definition. See how much I'm getting right now from this one. So what I can take common in this one, L naught of your copper is common. L naught of your copper is common into 1.7 divided by 1.1 minus 1 is equals to your 10. Minus 1 if I'm taking there, that will become for me plus. So that will become for me 11. So this will become for me, I'm writing here, see, L naught of your copper into 1.7 divided by 1.1. Let us see how much I'm getting right now. That comes out for me approximately 0.6. That is equals to minus 1. It goes here. That will become for me 11. So length of your copper is equals to 11 by 0.6. 11 by your 0.6 part of relation. See how much I'm getting that 11 by 0.6. 11 by 0.6 and this will become for me 6 by 10. That is nothing but of your 110 divided by 6. 6 ones are then 6. 12. So how much I am getting, you see? So it will become for me some around ones are then it is nothing but 18. That is nothing but some around 18.3. See it once again better. An iron rod and copper rod lie side by side. As the temperature is changed, the difference in the length of the rod, means the difference in the length of the rod remains constant. That's what I am using. Length of iron minus length of copper is equals to, that is given always for me 10. That is equation number 1. As there is an equal temperature per definition, so expansion in the iron must be equal to expansion in the copper. Then only this difference will remain for me same. That means whatever is an expansion in the iron, that should be the expansion in your copper. And you know how to write the delta L formula? Delta L is equals to initial length into alpha of your iron into temperature difference. That is equals to copper, alpha of copper into temperature difference. Temperature difference is remaining for me same, that gets cancelled. So that is equals to L naught of copper, alpha of iron is equals to L naught of copper into alpha of your copper. So from this one I'm getting L naught of your iron. L naught of your iron is equals to L naught of copper into alpha of copper divided by your alpha of your iron. So this is the way how do we calculate the value of this one. In this one, 2 are unknowns. I know the alpha of copper, I know the alpha of your iron. So I'm substituting that values. I'm taking that as equation number 2. Then I'm substituting equation number 2 in your equation number 1. Simplify it, we'll be getting the length of your copper. Once you get the length of your copper, you can substitute here. You can get the length of your iron also. Is it clear for everyone? Is it clear for everyone?
Yes, sir.
So length of copper in the 18.3 centimeters. Then what will be the length of iron beta? Can anyone tell me? What will be the length of iron? Length of iron means here I can write
18.3, sir.
How much?
18.3.
This is length of copper, now what we got? This is the length of copper. Length of copper is 18.3. Length of copper is 18.3. What is the length of iron then?
28.3.
28.3. 28.3. Got it, everyone? This one is your length of copper beta. Length of copper, how much you got? 18.3. That value we can substitute here in this one, isn't it? So that will give me the length of your copper. That is nothing but 18 point. If I'm taking this one minus here, this will become for me plus. I'm writing, you see, length of your what? Iron. Length of your iron is equals to 10 plus length of your copper. So that is nothing but 10 plus length of the copper is how much for me? 18.3. So that is equals to how much for me? 28.3 centimeters will be the length of your iron. Clear for everyone? Got it, beta?
Yes, sir.
Sure. Let us try to go for the next question, beta. Today I have sent you the NCERT materials beta. So please try to study for thermal expansion, do the solved examples and exercise problems given in that NCERT book. Right, next question, madam. Say for example, a pendulum clock consists of an iron rod connected to a small heavy bob. First of all, if it is designed to keep correct time at 20 degrees centigrade, comma, how fast or slow will it go in 24 hours at 50 degrees centigrade. Alpha of your iron is equals to 1.2 into 10 to the power of minus 5 per degree centigrade. A pendulum clock consists of an iron rod. Try to do it out, anyone. I already told you so many problems related to this one better. A pendulum clock consists of an iron rod connected to a small heavy bob. If it is designed to keep the correct time at 20 degrees centigrade, how fast or slow will it go in 24 hours? I told you the condition. I hope you remembered it. If your theta is greater than theta naught, then there is loss of your time. If theta is lesser than of your theta naught, then there will be gain in time. Okay. Theta naught is nothing but what? Temperature at which the clock will give the correct time beta. Theta naught is nothing but what? Temperature at which clock gives correct time. Okay. So theta naught is right now for me what? See the first condition right now. Theta naught is given how much for me? 20 degrees centigrade. And theta is given for me how much for me? 50 degrees centigrade. Now see the relation right now. There will be loss of time or gain of time. Your theta naught is right now. Theta is lesser than theta naught. So there will be gain
Loss
in
of time.
So if it is theta is greater than theta 9, that means there is a loss of time. So I can write here loss of time per day. Loss of time per day. I hope you got an idea how to identify which is losing and which is gaining better. You always try to keep this mind in the given condition. If your temperature is greater than of your temperature at which the correct clock is giving the correct time, then it will lose. If it is lesser than, it will gain the time. Here theta naught is 20 and theta is 50. So from this one, equation 1 is satisfying. So it will be loss of time. So loss of time per day will be equal to how much? What is the formula beta? Half into your coefficient of your iron. Iron is represented by the symbol Fe. Fe is the symbol of your iron into this is theta minus of your theta naught into 86,400 seconds. I told you this one. So this one is nothing but half into alpha of iron is 1.2 into 10 to the power of minus 5 into theta value is 50 minus theta naught is nothing but 20 into 86,400 seconds. I hope you can do this one. See how much I'm getting. Understand? Achinda. Let's simplify the powers better. Half into this is 12 by 10 into 10 to the power of minus 5 into 50 minus 20. This one is nothing but 30 into 86,864 into 10 to the power of 2. I can write this. Okay, now. So this one will be going up, this 0 and this 0 will cancel right now here. 10 to the power of minus 5 into 10 to the power of 2. That will be equal to 10 to the power of minus 3. 2 ones are 2 6 are, isn't it? So this one is how much I'm getting right now? 6 into 3 into 8, 6, 4 into 10 to the power of minus 5 into 10. That is 10 to the power of minus 3. See how much I'm getting that value better. This is 18. 18 into, if I remove this power beta, 1, 2, 3. That means this will become for me 0.864 into your 3, 5, 15, 3, 6, 18. That means it will be coming approximately 15.6 seconds. Vachinda chudanda sir andaru.
Yes, sir.
Got it, everyone? See, if I remove this power, how do you write this one beta? This value will become how much for me? 10 to the power of minus 3 it is. That means it is divided by 1000. 864 divided by 1000. That means if I am removing in terms of points, it will be 1, 2, 3. That means this will become for me 0.864 into, this one is nothing but how much for me? Vachin andarki?
Yes, sir.
No one is giving the answer. Only one student is responding. There are 20 students in the class.
Yes, sir.
Harshid Reddy.
Yes, sir.
Got it? Rashekar, Sai Vivek, Sai
Yes,
Kiran,
sir.
Syed Fayaz, Vivek, Yashwant, Shuswara, Arshit Reddy. Got it, everyone?
Yes, sir.
Sure.
Yes, sir.
So I
Yes,
hope you
sir.
got an idea how to do the problems related to the clocks, when to lose and when to gain. You got an idea. You try to keep this one always
Yes,
in the
sir.
mind. If your temperature theta is greater than theta naught is nothing but temperature at which the clock is giving the correct time. If it is theta is greater than your correct time, then it will lose. If theta is lesser than your correct time, then it will be gaining the time. Let us try to go for the next question first. Have you started doing the problems from that errorless book, beta? I
Yes,
sent you
sir.
the PDF of that one. Please try to do the problems in that one, beta.
Okay, sir.
Take this question, beta. Next question. A sphere of diameter 7 centimeter and mass 266.5 gram 266.5 gram floats in a bath of liquid. As temperature is raised, the sphere begins to sink. The sphere begins to sink at a temperature of 35.5 degrees centigrade. If density of liquid is 1.527 gram per centimeter cube at 0 degrees centigrade. Find the coefficient of cubical expansion. Find the coefficient of cubical expansion. Find the coefficient of cubical expansion of liquid. Neglect the expansion of sphere. Neglect the expansion of sphere. Good question, beta. Try to read the question carefully. See what exactly you are understanding from the given condition. We got a sphere of diameter, how much for me? 7 centimeter. That means radius will become for me how much? 7 by 2. 7 by 2 will be your radius of the given condition. So sphere of diameter 7 centimeter, mass is given as 266.5 grams. Everything is in the same unit, so no need of a conversion. Floats in a bath of your liquid. So in the first condition, so this is your liquid right now. This is your liquid, and this is your sphere right now somewhere. So this one is floating right now on this. Floating means this part will not be there right now. If it is slightly floating like this, so water is displaced, and this will be floating in the given condition. So that is a condition. As temperature of the water is being increased, as the temperature of water is being increased to 35 degrees centigrade right now, the sphere begins to sink. Now the sphere starts moving inside the liquid right now. It has started sinking at a temperature of 35.5 degrees centigrade. If the density of the liquid is 1.25 to 1.527 at 0 degrees centigrade, find the coefficient of the cubical expansion. That means gamma of the liquid. Neglect the expansion of the sphere. That means density of the sphere is how much better? Density of sphere at 0 degrees centigrade is equal to how much for me? 1.527 gram per centimeter cube. This is given, isn't it? Now, what should be the condition when it is been floating? Density of the liquid must be equal to your density of your sphere. I can say here right now, density of your liquid must be equal to your density of your sphere. Then only it will be floating. That means density at your 35 degrees centigrade. I am taking approximately that one as of your 35 beta. So otherwise calculation will become more difficult. You take this one as of your 35 degrees centigrade only. So density at your 35 degrees centigrade is equals to density. What is the density formula beta? Density is equals to mass by volume. Mass is given as of your 266.5 divided by volume. Volume is not given. Volume of the sphere will be equal to how much beta? 4 by 3 pi into your r cube. Can I write? So this one is 4 by 3 pi into your r cube. Radius is nothing but how much for me? 3.5 whole cube. Why? Diameter is equals to 2 times of radius. So radius is equals to diameter by 2. Diameter is 7 divided by 2. That is equals to 3.5. So that is the reason I got the density at your 35 degrees centigrade as of your 266.5 divided by 4 by 3. Pi value is nothing but 22 by 7 or 3.15 into 3.5 whole cube. You simplify it, we'll be getting the density at your 35 degrees centigrade. And you know that, what is the formula? Density at your T degrees centigrade is equals to rho naught into 1 plus gamma into your delta T. This is our formula. That means this will become for me, density at 35 degrees centigrade is equals to density at 0 degrees centigrade divided by 1 plus gamma into your temperature difference. That means I can write from this one, density at 35 degrees, whatever you get right now. We simplify this one. I'm using the calculator better. 266.5 divided by 4 by 3 into 3.14 into 3.5 into 3.5 into 3.5. It is giving approximately 1.484 gram per cc. Okay, so density at 35 degrees is 1.484. That is equal to density at 0 degrees centigrade is how much? 1.527 divided by 1 plus gamma we need to calculate, that is nothing but of your this. Temperature will be equal to how much for me? 35 minus another is 0 degrees centigrade. So from this one I can calculate the value of your gamma. So take this one here right now. This will become for me 1 plus 35 times of your gamma, because this is becoming for me 0. That is equals to 1.527 divided by 1.484. So it is 1.527 divided by 1.484 is approximately coming for me 1.029. So now can I get the value of your gamma from this one better? So if I take this value right now, if I take this one value here, that will become for me minus 35 times of gamma. I'm writing here 35 gamma is equals to 1 minus this one will become for me 0.029. This one it is going right now 1.029 minus 1 will be 0.29. That means gamma value is equals to 0.029 divided by 35. Divided by 35. That will come out for me approximately 3529. That is approximately 8.29. But I can write in terms of power this one. So this one is nothing but of your approximately 8.28 into 10 to the power of minus 4 per degree centigrade. You please check this calculation better. 0.029 divided by 35. See how much I am getting that value. I'll repeat this question once again better. Very good question, you see. A sphere of diameter 7 centimeter and mass 266.5 gram floats in a bath of a liquid. Initially, it has been floating. When it is been floating means density of the liquid must be equal to density of solid. Then only the body will be floating. In the swimming pools, you will be floating on the surface of water while doing swimming. Reason for that one is your density is equal to density of the liquid at that time. Then only you can able to float. Otherwise, you will be sinking. So if the density of the body is equal to density of liquid, then that is the condition for floating. Then density at 35 degrees centigrade is equals to mass by volume. Mass is given, volume is not given. Volume of the sphere I can write as a 4 by 3 pi into your r cube. Radius is not given, but diameter is given. So from that one, I'm getting the value of radius. Radius is equals to how much I got? 3.5 is your radius. That value is substituted it, and I got the density at 35 degrees centigrade as 1.484 gram per cc. Now you know the formula. We derived the formula for T degrees centigrade. Density at T degrees centigrade is equals to rho naught into 1 plus gamma into delta T. So density at 35 is equals to density at 0 degrees centigrade divided by 1 plus gamma into delta T. So simplify it, you will get the answer for the value of gamma, that is approximately 8.28 into 10 to the power of minus 4 per degree centigrade. Is this question clear with everyone?
Yes, sir.
Yes, sir.
Everyone?
Yes, sir.
Yes, sir.
I'm taking the next question now. The next question. A measuring tape. A measuring tape made of steel is calibrated at 5 degrees centigrade. If the coefficient of linear expansion, expansion of steel is 10 to the power of minus 5 per degree centigrade. Stop. If coefficient of linear expansion of the steel is 10 to the power of minus 5 per degree centigrade, comma, the percentage increase or the percentage error in measurement at 40 degrees centigrade is. This is a question. A measuring tape of the steel is calibrated at what temperature, beta? 5 degrees centigrade. And if the coefficient of linear expansion of the steel is alpha of the steel is given as 10 to the power of minus 5 per degree centigrade, then percentage, this one is right now the symbol of percentage, beta. Percentage error in the measurement at 40 degrees centigrade is equal to how much? Right hand under, sir. Scales concept I told you. measuring tape is made up of a steel is calibrated at 5 degrees centigrade. If the coefficient of linear expansion of the steel is 10 to the power of minus 5 per degree centigrade, the percentage error in the measurement at 40 degrees centigrade will be equal to how much for the given question. What is the formula, beta? True value is equals to scale reading into 1 plus alpha into your delta t. So I can write this one as true value divided by scale reading is equals to 1 plus alpha into delta t. So if I take this minus here, so this will become for me true value divided by scale reading minus 1 is equals to alpha into your delta t. In terms of percentage error means this will become for me true value for by scale reading minus 1 into your 100 is equals to your alpha into delta t into your 100. So if I'm doing with your other pen right now, see the calculation for this one. So this will become for me alpha value is given for me how much 10 to the power of minus 5 into delta t is equals to t2 minus t1, that is 40 minus of your 5 into your 100. That is equals to 10 to the power of minus 5 into this one is 35 into your 100. Then this will become for
0.0
35 into 10 to the
0.
power of your minus 3. Then 35 into 10 to the power of minus 3. That is approximately how much will become better for me. This is 0.035%.
0.035.
So true value minus scale reading minus 1 into 100. Percentage error in the measurement at 40 degrees centigrade means true value by scale reading minus 1 into 100 is a percentage error. That value comes out for me 0.035 percentage. Is it clear?
Yes, sir.
I hope you remember this value.
Yes, sir.
True value is equals to your scale reading into 1 plus of your alpha into delta t.
Yes, sir.
Clear for everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Sure. Take one more question. Try to do it faster. This is question number 4. If the temperature of a patient is 40 degrees centigrade, his temperature on the Fahrenheit scale is తొందర చెప్పండి. What is the answer for that one? Same way, one more question. The change in temperature of your body is 50 degrees centigrade. The change on the Kelvin scale. The change on the Kelvin scale is. Come on, try to do it out.
So first one is 212 Fahrenheit, degree Fahrenheit.
How much better?
212.
Fourth one, huh?
Yes, sir.
Sorry. Fourth question, what is the answer?
Sir, 104, sir. 104, sir.
Got it, everyone? What is the formula, beta? C by 5 is equals to F minus 32 divided by 180. The 5 is going to directly I can write here as of your 9. C value is given how much for me? 40. This is 40 divided by 5 is equals to F minus 32 divided by 9. So how much I'm getting the F value? F value is equals to. And that's something. Got it, everyone?
Yes, sir.
What's under key? 5 8s are. This is 8 9s are. This minus will come here. This will become for me plus. So F will become for me how much?
104, sir.
104 is your
104.
clear for everyone.
Yes, sir.
Chalo, next one. The change in temperature of the body is 50 degrees centigrade. The change on the Kelvin scale is. The change on the
270
Kelvin scale is. I'll give the options for this one. 50K. Second option is right now for me 323K,
323K, sir.
273K, and this one is 30K.
Sir, 323K, sir.
Sir, 50K.
23.
How?
50K.
Sir, it's the formula is
See, he's asking the change. Number of divisions you see. Number of divisions in degrees centigrade and Kelvin is always same, I told you. Have you got it? Change in temperature of the body is 15 degrees centigrade. What is the change on the Kelvin scale is asking? The change is always remaining for the same. That will be equal to how much for me? 50 Kelvin only. What is the number of divisions in the Kelvin and Celsius bed? I told you 100 divisions. So number of divisions of the change will always remain for the same. If the change in temperature of the body is 50 degrees centigrade, the change on the Kelvin scale is also equal to how much for me? 50 Kelvin. Got it? Achinda?
yes, sir.
Huh? Shall I tell you once again?
No, sir. Understood, sir.
Got it now? For the Celsius scale beta, this one is 0 degrees centigrade and this one is 100 degrees centigrade. Number of divisions is how much for me? 100. For Kelvin scale right now, down is 273.15 and here is nothing but 373.15. Number of divisions is how much for me? 100 divisions only, na? This one is also 100 divisions. In this one, if there are 50 differences, this should also be equal to 50 differences in the Kelvin only, na? So change in the temperature of a body, if it is 50 degrees centigrade, the same change on the Kelvin scale is also equal to how much for me? 50 Kelvin. Clear for everyone?
Yes, sir.
Yes, sir.
Tell me the answer for this question. But it is 9, 10 already. Okay. The Fahrenheit and Kelvin scale. Sixth question. The Fahrenheit and Kelvin scale, the Fahrenheit and Kelvin scales of temperature gives same reading at. Can anyone tell me the answer? Minus 40 degrees centigrade. Second option is 313. Third option is 574.23. And fourth option is 732.73. The Fahrenheit and Kelvin scale of the temperature gives the same reading at what temperature?
Sir, third one, sir.
How much?
574.23.
Very good. 574.23. 23 or nearby to your 25 approximately. What is the relation, beta? Fahrenheit and Kelvin, F minus 32 divided by 180 is equals to Kelvin. What is the relation? K minus of lower temperature 273 divided by upper temperature 373. If X is nothing but same temperature, the Fahrenheit and Kelvin scale of the temperature gives same reading. That means F and X must be equal to. If F is equals to K is equals to some X. Therefore, I can write that values right now here. So this will become for me X minus 32 divided by 180 is equals to X minus 273 divided by your 370. Clear for everyone? Isn't it?
Yes, sir.
This one is minus 273. This one is minus of 273. Means the number of divisions will become for me how much? 100. I'm taking directly. So this will also will become directly. I can take it as of your 100. So this one and this one will be gone right now. So it is X minus of your 32. That means I can simplify for the given condition. See how much I'm getting right now for this one. X minus 32 divided by 18 is equals to X minus 273 divided by 10. So it is X minus 32 into your 10 is equals to X minus 273 into your 18. So simplify for the value of your X, will be getting approximately 574.25. That means nearby answer what I can pick is right now for the third option. Clear for everyone?
Yes, sir.
Vachinandarki?
Vachin, sir.
We'll do some more problems in tomorrow's session of a class beta. And today I'll try to send you some questions with solutions. You please try to complete it before you come to the class for the tomorrow session. Okay? Okay, chalo beta. I'm taking leave. Bye.
Students, please wait for 5 minutes. Sir will join. Mass class will be start. Sorry.